In 1966, the Marston Road factory in Wolverhampton lost its independence. Villiers, the beating heart of the British light motorcycle industry, was absorbed into Norton Villiers, a move that effectively silenced an empire. This was not merely a corporate merger, it was the sudden collapse of a vast industrial ecosystem. Dozens of independent British marques, including Greeves, James, and Norman, had relied entirely on Villiers engines to survive. When the new corporate focus shifted toward large-capacity superbikes, the supply of small two-strokes evaporated, taking those historic assembly brands and a massive national parts network with it. Across the country, weekend shed mechanics lost a familiar machine. The British working class lost the simple, unkillable iron block that had carried them to the early shift for a generation. The paradox was brutal. The easiest engine to rebuild in Britain was ultimately defeated by an imported four-stroke that simply never asked to be rebuilt. But the real story of the Villiers two-stroke is not only the story of a Wolverhampton factory closing its doors, it is the story of how a simple iron block powered a generation of British working-class mobility until the world decided that power should no longer leave an oil stain on the driveway. Every week, we tell the stories of British engines, factories, machines, and industrial names that once taught the country what power sounded like and what happened when the market moved on. Subscribe if that history matters to you. The story begins not with nostalgia, but with a specific place in Wolverhampton, long before the age of austerity. The Villiers story did not begin with motorcycles. It began with bicycles, pedals, and the pragmatic ironworking culture of the West Midlands. In the late 19th century, John Marston had built a formidable reputation with his Sunbeam bicycles in Wolverhampton. The Sunbeam name stood for high-quality finishing, enclosed chain cases, and flawless black enamel. But as the new century turned, the bicycle alone was no longer enough. The public was beginning to demand mechanical power. Marston established the Villiers Engineering Company initially to manufacture cycle parts, operating out of a dedicated factory on Villiers Street. By 1912, under the guidance of Charles Marston and a fiercely capable engineer named Frank, the company realized that supplying mere components was a limited business. They needed to supply propulsion. Their first attempt was a conventional four-stroke engine, but it was their shift to a simpler concept in 1913 that sealed their fate and defined their legacy. They designed a 269cc two-stroke engine, an engine that completes a power cycle in two piston strokes, eliminating the need for complex valves and camshafts, trading some fuel efficiency for sheer mechanical simplicity and low manufacturing cost. That early 269cc block featured an integrated two-speed gearbox and was initially bolted into the frames of early Sunbeam motorcycles. It worked, but it was only a faint preview of the industrial scale that was coming. During the interwar years, Villiers did something that would define British light engineering for the next half-century. They stopped trying to build complete motorcycles and focused entirely on becoming the engine supplier to the nation. They perfected the flywheel magneto, an electrical generator built directly into the engine's rotating flywheel that provides a high-voltage spark for ignition without needing a heavy, unreliable external battery. This single innovation meant a Villiers engine could sit in a damp garden shed for a month, yet still start reliably on the second kick. It was a promise of absolute autonomy. By the late 1930s, the Marston Road factory was pouring out engines like the famous 9D, a 120cc unit that became the backbone of lightweight British transport. But to truly understand why Villiers became a sprawling empire, we have to look past the early engineering and look at the streets of Britain in 1946. This was austerity Britain. The Second World War was over, but the economic bleeding had not stopped. The country was exhausted, steel was strictly rationed, petrol was heavily controlled. The government's mandate was export or die, meaning the finest heavy motorcycles, the big Triumph Twins, the BSA Gold Stars, and the Norton Singles were being crated up and shipped to America to earn desperately needed foreign currency. Yet the British working class still had to get to work. A factory machinist in Birmingham, a dock worker in Liverpool, or an agricultural laborer in Yorkshire could not afford a Morris Minor car. They could barely afford a second-hand heavy motorcycle. The country faced a massive, urgent absence of cheap, reliable, utilitarian transport. Britain did not need luxury in 1946. It needed a cheap way to turn a cup of petrol into 20 miles of motion. Villiers stepped into this exact void. The Marston Road factory ramped up production of their small-capacity two-strokes, particularly the 122cc families, and the larger Torquier 197cc models. These engines were masterpieces of manufacturing economy. They required minimal raw materials compared to a heavy four-stroke. The iron castings were simple. The machining tolerances were forgiving enough to be mass-produced at high speed, yet precise enough to run for years without catastrophic failure. Villiers became the ultimate off-the-shelf power unit. If you had a workshop, a steady supply of steel tubing, and a welding torch, you could start a British motorcycle company. You didn't need a foundry to cast complex cylinder heads or a specialized machine shop to cut camshafts. You simply built a frame, painted it, attached some wheels, and ordered a crate of engines from Wolverhampton. This democratization of power birthed an entire ecosystem of British assembler marks. Dozens of names that would become legendary in the lightweight world: James Francis Barnett, Norman, Dot, Excelsior, Ambassador, and eventually the scrambles powerhouse Greeves, relied entirely on Villiers' power. They were independent, fiercely competitive brands on the petrol tank, but underneath the metal, they all shared the exact same Wolverhampton heartbeat. Surviving catalogs from the early 1950s show an astonishing reality. You could walk into a motorcycle dealer in Coventry or London and choose from a dozen different brands of lightweight commuter machine, all vying for the same customer, yet almost all powered by the identical Villiers 197cc iron barrel. The dealer network loved them. A mechanic only needed to learn one basic carburetor layout, one magneto system, and one piston clearance to service half the lightweight motorcycles in the county. Parts bins became universally interchangeable. A clutch plate from a ruined James could be fitted straight into a Francis Barnett on a Sunday afternoon. The 197cc variants, such as the widely used ADE, produced around 8 horsepower. It was a modest figure, but the torque was delivered low in the rev range, making it perfect for hauling a sidecar full of plumbing tools or pulling a rider up a muddy farm track. The engine was not fast, it was not silent. It vibrated, and it required the rider to manually mix two-stroke oil directly into the petrol tank, a ritual that left hands smelling of hydrocarbons and exhaust puffing a distinct blue haze across the nation's high streets. But in an era when money was tight, service stations were sparse, and transport was critical to survival. The Villiers two-stroke offered something more valuable than refinement. It offered mechanical trust. If a piston ring snapped, it could be replaced on a kitchen table. If a spark plug fouled, it could be cleaned on the side of a wet motorway with a piece of sandpaper. The block was ready. Britain simply had to bolt it into a frame, add a tank of mixed fuel, and open the throttle. The engineering reality that allowed Villiers to conquer Britain was rooted in a brutal, uncompromising economy of design. To understand why a generation of mechanics trusted it, one has to examine what was missing. The two-stroke engine, an engine that completes a power cycle in 2 piston strokes, eliminating the need for complex valves and camshafts, traded thermodynamic efficiency for sheer mechanical audacity. There were no poppet valves to burn out, no rocker arms to adjust, no heavy timing chains to stretch, and no complex oil pumps to fail. The piston itself acted as the valve, uncovering intake and exhaust ports in the cylinder wall as it traveled up and down the bore. For a nation recovering from war, this simplicity was a liberation. But Villiers did not merely build two-strokes, they perfected the peripheral systems that made them viable in the dampest British conditions. The cornerstone of this reliability was the flywheel magneto, an electrical generator built directly into the engine's rotating flywheel that provides a high-voltage spark for ignition without needing a heavy, unreliable external battery. In a British winter, when damp air routinely strangled conventional electrical systems, a Villiers flywheel magneto delivered a sharp, dependable spark the moment the kickstart lever was driven downward. It meant a courier could leave a machine parked in an alleyway through a freezing West Midlands drizzle and still fire it up with a sharp jab of the foot. The breakthroughs came in specific, numbered displacements that soon became household terms across the workshop floors of Britain. The 9D and its descendants, followed by the ubiquitous 102cc and 197cc engines, established a formidable technical baseline. The 197cc units, such as the famous ADE and subsequent models, utilized a straightforward aluminum alloy piston running inside a cast-iron cylinder barrel. The carburetor was typically a Villiers' own design instrument, a masterpiece of minimalist brass and alloy construction that could be completely stripped down using nothing more than a standard flathead screwdriver and an adjustable spanner. A mechanic sitting on an upturned crate outside a rural garage could remove the float chamber, clear a block jet with a piece of copper wire, and have the engine running again in 10 minutes. This accessibility created a profound user moat. When brands like James, Francis Barnett, and Norman bolted a Villiers 197cc unit into their frames, they were not just selling a motorcycle, they were selling a guarantee of independent maintenance. The engines bore in stroke dimensions, such as the classic 59mm by 72mm layout of the popular 197cc engine, were stamped into trade catalogs and memorized by every apprentice mechanic from Land's End to John O'Groats. Yet the Marston Road factory did not limit its ambition to two wheels. The exact same metallurgical formulas and basic architecture were scaled and adapted to power an astonishing array of British industry. If you walked onto a mid-century farm in Cheshire, you might find a Villiers stationary engine chugging away in a damp shed, driving a milking machine or a water pump through a flat leather belt. If you visited a municipal park in Manchester, a motor scythe cutting the grass was likely driven by a Villiers lightweight block. Most poignant of all were the invalid carriages, the small, single-seat three-wheelers issued by the Ministry of Pensions to disabled veterans and civilians. Thousands of these blue government-issue invalid carriages relied on Villiers engines to maintain personal mobility when public transport was inaccessible. The engine had conquered the road, the field, and the factory floor, but its greatest triumph was not in the sales catalog, it was in the British shed. By the mid-1950s, the Marston Road factory in Wolverhampton was no longer just an engineering firm, it was a national heartbeat. The Villiers name dominated the British lightweight motorcycle market with an absolute crushing monopoly. Surviving company records indicate that in 1956, the factory celebrated the production of its 2 millionth engine. At its absolute zenith, Villiers was supplying power units to over 100 different manufacturers globally. But its core domain remained the streets, fields, and factories of Britain. If a British motorcycle displaced less than 250cc, there was an overwhelming probability that it relied on a Villiers block. The scale of manufacturing at Wolverhampton was immense. Foundries poured molten iron for cylinder barrels and cast aluminium for crankcases in a continuous, deafening rhythm. Machining lines cut ports and threads with relentless repetition. The finished engines were packed into wooden crates and shipped by rail and lorry across the country. They arrived at the James factory in Greeves, the Francis Barnett assembly halls in Coventry, and the Norman Works in Ashford. These assembler markets did not need to invest in engine research or metallurgy. They simply unbolted the wooden crates, hoisted the Villiers units onto their own production lines, and painted their logos on the fuel tanks. But the true glory of the Villiers engine in this era was not found on the polished showroom floors. It was found in the mud. Motorsport in Britain has always dictated engineering prestige, and in the 1950s, the rural obsession was scrambles. Scrambles, the brutal, natural terrain off-road racing that would eventually become known as motocross, was traditionally dominated by heavy, thunderous, four-stroke singles from companies like BSA, Matchless, and Norton. These machines produced immense power, but they were heavy, and a heavy motorcycle sinks in deep British winter mud. Then came the lightweight revolution, spearheaded by a fiercely inventive engineer named Greeves, operating out of Thundersley in Essex. Greeves realized that absolute horsepower mattered less than weight, agility, and traction. He built a radical, lightweight frame featuring a cast aluminium beam, and into this frame, he bolted a Villiers two-stroke engine. Initially using the 127cc 9E and later the more powerful 246cc 32A and 34A units, the Villiers block became a formidable racing weapon. The 9E featured a stronger crankshaft, the rotating shaft that turns piston motion into rotational power, and a reinforced four-speed gearbox. It was fundamentally the same simple iron and aluminum architecture that powered commuter bikes, but tuned for aggressive, instant torque. In a British scrambles paddock on a freezing Sunday morning in 1958, there were no multi-million-pound factory race transporters. There were Bedford vans, open trailers, and privateer mechanics in waxed cotton jackets, rubbing their hands against the cold. The air was thick with the sharp, sweet smell of castor oil and the high-pitched, frantic ring-ding of two-stroke exhausts clearing their throats. When the starting flag dropped, the heavy four strokes would roar toward the first corner, but as the track deteriorated into a quagmire, the Villiers-powered Greeves, Dot, and Cotton motorcycles would dance over the ruts. If a rider dropped a Greeves in a muddy ditch, he could pick it up, clear the simple Villiers carburetor, and kick it back into life. If an engine seized from heat and abuse, the cylinder head, the upper cap of the engine that seals the combustion chamber, could be removed in the paddock with a basic spanner, a new piston fitted, and the machine returned to the track in time for the afternoon heat. This was the ultimate garagist economics applied to dirt racing. Villiers was supplying a cheap modular platform that allowed small British constructors to take on the giants of the industry and win. A privateer rider did not need factory backing to be competitive. He only needed a Villiers engine, a set of files to enlarge the exhaust ports for more power, and the nerve to keep the throttle pinned open. The idea was intensely British, raw, unpretentious, highly adaptable engineering that conquered the mud through sheer, bloody-minded simplicity. But while the racing glory built the myth, the true scale of the Villiers empire was built quietly, away from the track, in millions of working-class homes. While the racing glory built the myth, the true scale of the Villiers empire was built quietly, away from the track, in millions of working-class homes. By the late 1950s, the Villiers engine was not just a product, it was a defining characteristic of the British environment. Every weekday morning, shortly before 6 o'clock, the terraced streets of industrial towns from Coventry to Glasgow would echo with a distinct, frantic popping sound. This was the sound of the British commute. Hundreds of thousands of riders on lightweight machines, riding a James Captain, a Francis Barnett cruiser, or a Norman B-20, were kicking their engines into life. The air would quickly fill with a thick blue haze. This haze was the physical signature of the petrol mixture, a fueling method where two-stroke oil is manually poured directly into the petrol tank and shaken to mix, because simple two-stroke engines do not possess a dedicated internal oil sump or mechanical oil pump to lubricate their moving parts. At the local garage, buying fuel was a ritual. The rider would dispense a gallon of petrol, then use a small, often heavily dented metal measuring cup to add the exact ratio of thick oil required. It was a messy, imprecise science that left hands permanently smelling of hydrocarbons, but it was universally understood. Because the engine burned oil by design, it created a byproduct, carbon. Over time, hard black carbon deposits would build up inside the cylinder head and block the exhaust ports, gradually suffocating the engine and robbing it of power. In a modern context, this would be a catastrophic design flaw requiring a dealer service. In 1950s Britain, it was simply an excuse to spend Sunday morning in the shed. The shed mechanic culture was the ultimate expression of the Villiers empire. A factory worker might not have owned the terraced house he lived in, and he certainly did not own the heavy machinery he operated from Monday to Friday. But in his garden shed, leaning over a wooden workbench stained with years of spilled oil, he possessed absolute mechanical sovereignty. Decarbonizing a Villiers engine was a national weekend pastime. Because the engine was so accessible, a rider could remove the cylinder head with a basic spanner, lift the barrel away from the piston, and use a piece of soft wood or a blunt scraper to clear the carbon from the ports. There were no complex valve timings to realign, no camshafts to retime, and no delicate tensioners to reset. If you dropped a component on the sawdust-covered floor, you picked it up, wiped it on a rag, and put it back in. The tolerances were generous. The engine was fundamentally on the side of the owner. This extreme accessibility turned the Villiers engine into a mechanical classroom for an entire generation of British youth. Before a teenager could ever hope to afford a motor car, they bought a third-hand, battered, lightweight motorcycle. By stripping down the simple brass float chamber of a Villiers carburetor, they learned the fundamental principles of fuel delivery. By setting the points on the flywheel magneto, they learned the laws of electrical timing. The Marston Road factory was not merely producing power units. It was mass-producing mechanical literacy. The service network that kept these machines running was vast and deeply informal. While official dealers existed in every major town, the real support network was the community. Spare parts were universally interchangeable and aggressively cheap. If a piston ring failed, a replacement could be sourced from the local motor factor, or even borrowed from a neighbor's dismantled lawnmower. The ecosystem was entirely self-sustaining, built on a foundation of cast iron, cheap spares, and shared working-class knowledge. In a Britain where an engine could decide whether a factory worker made it to the early shift, a farmer pumped water from a flooded field, or a weekend rider scrambled up a muddy hill, power was not an abstraction. It was iron, two-stroke oil, a basic spanner, and the trust that whatever broke could be fixed on a Sunday afternoon. The sound of Wolverhampton was everywhere, but the very simplicity that made Villiers a national habit was about to become its greatest vulnerability. The first crack in the Villiers empire did not happen on a racetrack, nor was it announced in a corporate boardroom in Wolverhampton. It happened on a wet Tuesday morning at a local garage, when a rider wearing a clean suit decided he was tired of having two-stroke oil on his hands. For decades, the ritual of the petrol mixture, measuring thick two-stroke oil into a dented tin cup and shaking the motorcycle to mix it with the petrol, had been an accepted price of mobility. Because simple two-stroke engines lack an internal oil sump, the fuel itself must carry the lubrication to the piston and crankshaft. But as the 1950s bled into the 1960s, Britain was changing. Austerity was fading. The working class had slightly more disposable income, and expectations regarding daily transport were shifting. A motorcycle was no longer just a desperate alternative to walking. It was a consumer product. Consumers were beginning to ask why their clothes had to smell like burnt hydrocarbons before they even arrived at the factory gates. The turning point arrived by ship. In the late 1950s and early 1960s, Japanese manufacturers, led most aggressively by Honda, began unloading a new kind of machine onto British docks. The Honda Super Cub step-through was not just a different motorcycle, it was an entirely different philosophy of mechanical ownership. The Honda was powered by a small-capacity four-stroke engine, an engine that completes intake, compression, power, and exhaust strokes across four distinct piston movements, keeping the lubricating oil neatly contained in a dedicated lower sump. The rider did not have to mix oil and fuel in the freezing rain. They simply filled the tank with pure petrol from the pump. Furthermore, the Japanese machine featured an enclosed drive chain that did not ruin trousers, a semi-automatic gearbox that required no heavy clutch lever, and most devastatingly of all, a reliable electrical system. Against this quiet, clean efficiency, the traditional Villiers 197cc two-stroke suddenly felt archaic. The British engine vibrated aggressively. It required routine decarbonization to scrape the burnt oil from the exhaust ports. It suffered from whiskering, a frustrating condition where a tiny bridge of carbon shorts out the spark plug gap, requiring the rider to stop by the side of the road, remove the plug, and clean it with a wire brush. But the real threat was not just the mechanical refinement of the Japanese imports. It was the psychological shift they caused within the British service network. For years, British motorcycle dealers had sold the Villiers engine on the promise that when it broke, the owner could fix it in a shed with a basic spanner. The Honda Super Cub arrived with a terrifying new promise for the British industry. It would simply not break. The market force of convenience was brutally displacing the market force of repairability. A new generation of riders did not want to learn how to clear a blocked brass carburetor jet or regap a flywheel magneto. They wanted to turn a key, press a button, and arrive at their destination with clean fingernails. The very simplicity that had made Villiers a national habit was now being viewed as primitive. Sensing this shift, the engineers at Marston Road attempted to fight back, but they critically misunderstood the nature of their own empire. Instead of building a refined, clean, reliable commuter engine to rival the Japanese step-throughs, Villiers decided to chase high performance. In 1963, they introduced the StarMaker engine. It was a 247cc two-stroke designed specifically for racing and high-performance road use. On paper, it was a masterpiece of output, producing a claimed 25 horsepower at 6,500 RPM. To achieve this, Villiers equipped it with twin Amal carburetors, a high-compression cylinder head, and a heavily revised porting layout that pushed the basic piston port architecture to its absolute limit. But the StarMaker betrayed the fundamental promise of the Villiers name. It was highly strung and deeply temperamental. The twin carburetors required precise, painstaking synchronization, a task that frustrated the traditional shed mechanic who was used to the simple, single-instrument layout of the old 9E commuter blocks. The StarMaker was notoriously peaky, delivering its power in a sudden, vicious surge that made it difficult to ride in traffic and exhausting to manage on a scrambles track. More importantly, it suffered from severe reliability issues. The engine ran incredibly hot. The traditional Villiers manufacturing tolerances, which were loose enough to forgive a missed oil mixture in a commuter bike, were simply not tight enough to withstand the extreme thermal stresses of a racing tune. The StarMaker seized pistons. It broke connecting rods. It overheated in the mud. The engine that had built its reputation on unkillable durability was suddenly gaining a reputation for fragility in the paddock. The racing teams that had once sworn by Wolverhampton iron began to look elsewhere. Even loyal British brands like Greeves, who had built their scrambles' dominance on Villiers' power, realized they could no longer rely on the factory. Greeves began designing their own cylinder heads and eventually their entirely own engines to remain competitive against lighter, faster, specialized European two-strokes from Bultaco and Husqvarna. Villiers had abandoned the commuter to chase the racer, and in doing so, they had alienated both. The foundation was cracking, but the true collapse of the empire would come not from the engineering department, but from the boardroom. While Villiers struggled to find a technical answer to the shifting market, the industrial ecosystem that supported them began to implode under the weight of terrible financial decisions. The dozens of independent British assembler marques, brands like James, Francis Barnett, and Norman, had no engine development departments of their own. They were entirely dependent on Wolverhampton to supply the heartbeat of their machines. As the Villiers commuter engines began to look outdated and sales plummeted, these smaller factories found themselves in a fatal trap. They did not have the capital to design their own modern four-stroke engines, and Villiers was not offering them one. The dealer network, which had once relied heavily on the constant turnover of Villiers spare parts, started clearing their showrooms to make space for Japanese machinery. A motorcycle dealer in Birmingham or London quickly realized it was far more profitable to sell a reliable Honda that required a scheduled paid service in the professional workshop than to sell a smoky Villiers that the owner would stubbornly repair themselves in a garden shed. The vast informal supply chain of cheap cast iron spares began to dry up. By the mid-1960s, the financial situation across the British motorcycle industry had become desperate. Associated Motorcycles, AMC, the massive industrial conglomerate that owned Matchless, AJS, Norton, and crucially, the lightweight assemblers James and Francis Barnett, collapsed into bankruptcy in 1966. The collapse of AMC severed a massive, vital artery of Villiers sales. Without James and Francis Barnett ordering hundreds of crates of engines every month, the Marston Road production line slowed to a devastating crawl. The economy of scale that had made the cheap, mass-produced two-stroke profitable evaporated almost overnight. A factory built to produce millions of engines cannot survive by building a few thousand. In 1966, the financier Dennis Poor and his engineering group, Manganese Bronze Holdings, stepped into the wreckage of the British industry. Poor orchestrated a massive, ruthless corporate consolidation, acquiring the bankrupt remains of AMC and merging it with Villiers to create a new sprawling entity, Norton Villiers. On paper, the Villiers name had survived. In reality, it was an industrial execution. The strategy of the newly formed Norton Villiers Corporation was entirely focused on the lucrative American export market. The Americans wanted large-capacity, heavy four-stroke superbikes that could cover vast highway distances. They wanted the prestige of the Norton Commando. They had absolutely no interest in a small, smoky 197cc commuter, two-stroke from the West Midlands. Dennis Poor ruthlessly slashed the unprofitable lightweight divisions. The historic James and Francis Barnett brands were unceremoniously killed off, wiping out decades of brand loyalty. The vast, diverse catalog of Villiers industrial engines, stationary engines, motor scythes, and invalid carriage motors was starved of critical investment. The Marston Road factory, which had once poured out the engines that mobilized the British working class, was rapidly and quietly reorganized. Instead of casting two-stroke blocks and assembling flywheel magnetos, the Wolverhampton workforce was instructed to manufacture frames, forks, and cycle parts for the heavy Norton twins being assembled down south. The engine division that had powered the nation was effectively shut down, reduced to a mere supplier of fabricated metal components for another brand's ambition. The collapse of the Villiers network was devastatingly quick because it was entirely systemic. Because the brand had relied on an ecosystem of independent assemblers, there was no single dramatic factory closure that made the front pages to mark the end of the two-stroke era. It was instead 1,000 small, quiet deaths across the country. Small motorcycle repair shops that had existed solely to rebore Villiers, iron cylinders quietly closed their doors and were sold off. The local motor factors stopped stocking the classic points and condensers. The distinctive blue haze of the petrol mixture began to clear from the morning commute, replaced entirely by the clean exhaust of Japanese four-strokes and the rising tide of cheap, enclosed British motor cars like the Mini, which offered the ultimate protection against the British weather. The tragedy was not that the Villiers engine had broken. The iron blocks were as durable as ever, and a 187cc engine built in 1955 would still start on the second kick in 1970 if given a fresh spark plug. The tragedy was that Britain no longer wanted to ride them. The working class had ascended to the enclosed comfort of the motor car, and the remaining lightweight motorcycle market demanded a level of electronic sophistication and cleanliness that Wolverhampton was never funded to build. The engine still ran, the orders slowed, the assembly line stopped. The parts grew scarce, the factory line moved, the blue smoke cleared, the badge became a memory, the sheds went quiet. The corporate entity that absorbed the Wolverhampton empire did not survive the decade. Norton Villiers evolved into Norton Villiers Triumph, a sprawling government-backed conglomerate that eventually collapsed under the weight of industrial strikes, Japanese competition, and disastrous management in the 1970s. The great Marston Road factory, which had once poured out millions of two-stroke engines, was eventually silenced, shuttered, and demolished. Today, if you walk through that specific part of Wolverhampton, you will find modern housing estates and quiet streets. There is no foundry noise, no smell of hot aluminum, and no frantic popping of two-stroke commuters leaving the factory gates at the end of the shift. The industrial ecosystem that built the British lightweight motorcycle is entirely gone, but the engines themselves refuse to disappear. Old British engines rarely vanish cleanly, and the Villiers block was produced in such staggering numbers that it became a permanent geological layer in the British mechanical landscape. Today, if you walk into a British auto jumble at Beaulieu, Stafford, or Netley Marsh on a damp Sunday morning, the Villiers empire is still scattered across the trestle tables. You will see cardboard boxes filled with brass carburetor floats, aluminium pistons wrapped in oiled paper, and cast iron cylinder heads sitting next to oil-stained service manuals with black thumbprints still visible on the pages. The parts network that once kept the nation moving has survived as a thriving preservation economy. Because the engines were designed to be completely modular and the manufacturing tolerances were so generous, a restorer today can easily assemble a complete, running Villiers 197cc engine, entirely from parts scavenged from different auto jumble bins. The sound has survived too. Visit a vintage scrambles paddock at a classic off-road meeting, and you will not find the quiet, electric hum of modern sport. You will find a scene that perfectly mirrors a 1958 Sunday afternoon. Bedford vans and open trailers are parked in the mud. Mechanics in waxed cotton jackets are adjusting the points on flywheel magnetos with feeler gauges. And when the starting flag drops, a pack of Villiers-powered Greeves, Dot, and Cotton motorcycles still tears across the dirt, trailing that unmistakable, sweet blue haze of burning petroleum mixture. They are still loud, they are still vibrating, and they are still being rebuilt on upturned crates in the paddock. Yet the survival of the Villiers engine is not limited to classic motorcycles and racing. The surprise footnote of the Marston Road story is found far away from the roads. Deep in rural Britain, in damp agricultural sheds, old railway yards, and neglected corners of industrial estates, Villiers' stationary engines are still working. There are farmers who still rely on a battered 50-year-old Villiers single to drive a water pump or a generator, simply because the iron block has never failed. It outlived the company that cast it, the dealer network that sold it, and the original owner who bought it. This enduring presence is not mere nostalgia. It is easy to romanticize the past and forget the fouled spark plugs, the messy oil mixing, and the freezing mornings spent kicking a stubborn engine. But preserving a Villiers two-stroke today is a physical argument about a vanished relationship between a human being and a machine. Modern transport is governed by software. A modern motorcycle or motor car is a sealed, rolling computer network. If a sensor fails, the machine stops, and the owner is entirely powerless to fix it without proprietary diagnostic software and a professional technician. Power has become a black box. The user is no longer a mechanic. They are only a consumer. A Villiers engine represents the exact opposite philosophy. It is the ultimate expression of working-class mechanical autonomy. When a British writer bought a Villiers-powered machine in 1955, they were buying agency. They could see the fuel enter the carburetor. They could understand the spark leaving the magneto. They could dismantle the entire power unit with a handful of basic spanners, clean the carbon from the exhaust ports, and put it back together without asking anyone for permission. The Villiers engine did not hide its function. It demanded that the owner participate in its survival. Britain did not stop needing transport. It simply stopped wanting to participate in it. The market chose convenience, cleanliness, and the reliable hum of Japanese four-strokes and electric starters. The country traded the oil stain on the driveway for a machine that never needed to be opened. What vanished when Marston Road closed was not just a manufacturing plant. It was an era when ordinary people trusted their own hands to keep the country moving. Somewhere in a Midlands shed, an old Villiers 197cc block still sits on a wooden workbench, the cast iron dulled by decades of dust, the brass carburetor tarnished, waiting for a simple repair that the new world no longer needs to make. See you in the next video.